Here's another example where we've got a non-uniform rod. So in this case, we've got non-uniform rod AB, which is 3 meters long, has weight 20 newtons. It is in a horizontal position resting on supports at points C and D, where AC is 1 meter and AD is 2.5 meters. The magnitude of the reaction at C is 3 times the magnitude of the reaction at D. Find the distance of the center of mass of the rod from A. So, as always, we need to have a nice clear diagram before we do anything. So start by drawing a rod, i.e. a straight line. So when you do diagrams, make them nice and big, which makes life easier basically. So we say A is going to be this end, B can be this end, and we're told that it's 3 meters long. It is resting on supports C and D, so AC is 1 meter, AD is 2.5 meters, so 1 meter here for the sake of argument to C, and 2.5 meters to D, so that really means it's 0.5 meters from B in fact, so we can label that on. We have got a weight of this rod, so the weight is 20 newtons rather than a mass, so that means that we are just labelling a force of 20 newtons, so that's going to be somewhere in between C and D for the sake of argument. So let's label that on as 20 newtons. The other forces we've got the reactions at C and D. So we're told that the magnitude of the reaction at C is 3 times the magnitude of the reaction at D. So let's call the one at D R. So that means the one at C is 3 times by that, so 3R. We're trying to find where the centre of mass is. So in fact, we want the distance of the centre of mass from A. So we're going to label that as x meters here. So the question is going to involve taking moments at some point, but the first thing we can actually do is work out what R is. So the two upward forces, 3R and R, they must balance with a 20 Newton force. So in other words, we need to say 3R add R take 20 is equal to 0. So 4R equals 20. So R must be equal to 5 newtons. The next thing we can do is take moments. So we might as well take moments about A, seeing as we've got what R is equal to now. So if we take moments about A, we've got to think about which force is going to clockwise and which one's going to go anti-clockwise. So the weight to the rod, if we fixed A in place, that 20 Newton force is going to be pushing downwards. So that means it's going to be positive because it's going to be clockwise. Whereas the 3Rs and the R force, they're going the opposite way. If you imagine sort of pulling there, you'd be pulling the rod anti-clockwise. And similar with the 3R force. So they're going to be negative in this example. So we're just going to take moments now. So we're going to have the 20 Newton force times by x. It's going in the positive direction. The other two forces are going to give negative moments. So I'm going to subtract 3R times by the 1 meter from A. And R is 2.5 meters from A. So remember that was actually given in the question anyway. And that's going to go anti-clockwise. So I'm going to call that negative. So R times 2.5. And they're all cancelling each other out. So therefore they must be equal to 0. So we're going to get 20x, take 3R, take 2.5R is equal to 0. So in other words, 20x is equal to 5.5R. But earlier we did work out that R was 5 newtons, so we can substitute that in. So 20x is equal to 5.5 times 5, which is 27.5. So therefore x would be 27.5 over 20, which is going to be 1.325 meters. That's kind of it really, because the question was wanting us to find the distance of the centre of the mass from rod A. But just to make it really clear about what we've actually worked out, let's just finish the question by saying the centre of mass is 1.325 meters from A. Just to spell it out really clearly for anyone who's marking the work. which is down there.